Hi there, welcome to Machine Bytes, your go-to place to learn AI the smart way. In last video, we had an overview of what AI is. In today's video, we will explore its subfields more. As you already know, AI is the capability of system to learn from the data. This field is there in the market for about a century now, but the application which made a buzz in the market was rolled out in 1990s, which was spam filter. This application impacted millions of people and hyped the AI field. Let's understand why AI is needed and why some problems can't be solved using the conventional method. Take the same example, spam filter. So if we want to solve this problem using conventional programming methodology, what we will do is identify the words which are there in the spam mails. Then we will write an algorithm to find out those words in the mails. And third, we will block or mark spam such mails. Now we will repeat all these steps until we are good enough to roll this application out into the production. With this approach, to identify words is a tedious task because the list will be huge. And then we will mark the email, spam, or ham on the basis of this list. Suppose now you have blocked the emails with words like credit card, offer, free for you. But now spammers know that you are blocking all these words, so they will also upgrade themselves. And instead of writing free for you, they may start writing like free for you. Because you have hard coded these words in your programming algorithm, your program will not be able to mark this email as spam. There comes the AI in the picture. Using AI, you do not need to define these words manually. The algorithm itself will identify the words and block such emails or mark them spam wherever those spam words are found. And what if the spammers upgraded themselves? Then again, the algorithm will be able to identify which emails are spam and will upgrade its words list accordingly. As discussed in the last video also, these are the subfields of AI. AI is an umbrella term. Under that, we have machine learning, we have neural networks, and we have deep learning, generative AI, we have LLMs, and then we have NLP. Let's explore these further. Machine learning is the field of AI where we have some algorithms, or you can say models, defined, and using them we predict the values for the future events. Now how that is done is we have the past data that is provided to the model learns from it, and then it will predict the values in the future. So for machine learning algorithms, there can be two kinds of problems where either we will predict a value, which is called the regression problem, or we will predict the class, that is called the classification problem. This process is repeated until we get the desired accuracy. And to calculate accuracy, we have different methodologies for regression and classification problem. These are the some of the applications that can be achieved using the machine learning algorithms, like fraud detection, where we will mark if some transaction or credit card payment or insurance claim is fraud or not. Then we have recommendation systems. We have customer segmentation, for which will be a classification problem. Then we have predictive maintenance, credit scoring, and price optimization. All these problems can be solved using ML algorithms. Let's move to DL. End-to-end flow of deep learning problems is similar to machine learning only, where we have some data using which model will learn and then predict the values for the future. Here there will be some accuracy metrics using which we will calculate whether our model is performing as per our expectations or not. The difference here is in the process of how models are predicting the values. Deep learning is based on how human mind thinks. So the basic unit of deep learning is called neuron. In deep learning, its structure is like if we have these much features, then there will be different layers like this. These features will be passed on to these layers. And then if there are two classes that are expected in the output, there will be two classes like this, and we will get the output. So there will be different layers. These are called the layers, and these circles are called the neurons. This is how DL works in the background. Now, since deep learning and machine learning are performing similar kind of tasks, you might be confused where to use what and why do we need deep learning when we already had machine learning. Let's understand that. I have noted down some high level points where machine learning and deep learning algorithms differ. If we talk about the models, machine learning has comparatively simple models, while deep learning uses the complex models where different layers of neurons are used. In machine learning, models are like linear regression, logistic regression, then we have support vector machine, we have decision trees. Like that, there are multiple algorithms. If we talk about features, in machine learning, we need to manually extract the features and work on them. While deep learning, no manual feature extraction is done. It is done by default in the layers. If we talk about the interpretability of the results, it's easier to interpret why some output is given to a user using machine learning algorithms because we have a defined set of process that is followed by the algorithms. But in case of deep learning algorithms, there are multiple layers of neurons that are used, hence it is not possible to interpret the result. If we talk about the amount of data that is required, ML algorithms can be created using a low to medium range of data, while for deep learning algorithms, we need large amount of data. But when we talk about the complexity, ML algorithms can work with only low complexity data, while deep learning algorithms can work with high complex data like audio, videos, or images. If we talk about hardware, ML algorithms can be executed on CPUs, while deep learning algorithms will require GPUs or high performing devices to work with. Because of the complexity of deep learning algorithms, they will take more time to train the model, while ML algorithms can be trained in comparatively less time. So, in all and all, if we have simple data and we want the results to be interpretable, we will use machine learning. But if our data is complex and we have high volume of data, we can go for the deep learning algorithms where accuracy will be higher. The next subfield is NLP, which is natural language processing. NLP is used where text is involved. So using NLP, one can create models where we can do sentiment analysis. Chat bots can be created. Other applications of NLP are given here. To create the NLP algorithms, one can use either machine learning models or deep learning models. And to handle the more complex NLP problems, LLMs can be used. Let's talk about generative AI. The additional feature that is there in generative AI, apart from other subfields, is content creation. So, using generative AI, we can create new text, we can create images, videos, all that features are there additional to the prediction that was there in other subfields. These are the high level applications of generative AI text generations. The chat GPT is one of the example of that. Then we have image generation, code generation, video generation, content personalization, synthetic data generation, design assistance, and voice cloning. These are some of the applications that can be achieved using generative AI. That's all for this video. I will see you in the next one. Till then, thanks and bye bye. Take care.